start with Baccalaureate Series. So we have here f of x is equal to sine raised to 2 times x. So first we have f of x is equal to sine raised to 2 times x. So first let's do the first derivative, which is equal to 2 cos x sine x, which is equal to sine of 2x. Next is your second derivative. This is equal to your line chain rule, so it's 2 cos 2x. For your third, again using the chain rule again here, it's become negative 4 sine 2x. Your fourth, again chain rule here, it's become negative 8 cos of 2x. Your fifth, again chain rule, this will become 16 sine of 2x. And your sixth is equal to, again, sine, your chain rule again, so it's 2 cos x. So we stop here, then we plug it in the formula. So when x is 0, this becomes 0 plus, so when your x is here 0, the whole thing, sine of 2 times 0, just 0 over 1 factorial times your x plus here cos 2 times 0, that will be 1 times 2, so it's 2 over 2 factorial times x squared plus here, you know, sine 0 is 0, so 0 over 3 factorial x cubed plus here cos is a big one, so it becomes negative 8 over 4 factorial x to the 4. Now plus sine, this becomes 0 all over 5 factorial x raised to 5. Here we have your cos, so cos is equal to 1 plus 32 all over 6 factorial x to the 6. Now we sum it all up and simplified it. So here cancel, this become x squared minus, we have here, this become 1 third x to the 4th. Next we have here plus 2 over 45 x 6 plus dot dot dot, meaning we have more series, but that's okay, we have the first three. That's my final answer. So mostly I'll be answering the even numbers given by teacher. So this is my number 4. So here we have here arc sine of x. So again, start off here. First derivative, arc sine is actually 1 over square root of 1 plus x squared. So your second here, we can use here the chain rule. Just move this up here. So this will become x all over 1 minus x raised 1 minus x squared raised to 3 halves. Your third, again chain rule. So this will become 2x squared plus 1 all over 1 minus x squared raised to 5 halves. Your fourth, you can have here your quotient rule, and this become your 3x multiplied by your 2x raised to 2 plus 3 all over 1 minus x squared raised to, this become your 7 halves. So we stop here. So now we simplified. So when x is 0, arc sine is just 0 plus here when your x is 0, this become 1 all over 1 prime 1 factorial times x plus here when your x is 0, so we have 0 on top, so this becomes 0 all over 2 factorial x squared. Here when x is 0, so this will be 1, so 0. What's left here is just 1 x factorial x raised to 3. Lastly, your fourth, when your x is 0, so whole thing becomes 0. Raised to 4. Simplified, so we have here x plus this become 1 over 6 x raised to cube plus so on and so forth, because it's hard to derive when it gets higher and higher. So this is my final answer for my number 4. Okay, so this is my number 6. So now we're gonna use the Taylor series. Okay, so first let's find the first derivative. So this will be easy. So we have here power rule. So it becomes 6x minus 6. So your second derivative of this is equal to 6. And your third is equal to 0. Now, let's simplify. So when your x here is 1, is equal to 2, plus when your x is 1 here, this will become 0 all over 1 factorial x plus when 6 here, so there's no x, so we can have here 6 2 factorial of x minus 1 is to 2. Don't forget here x minus 1. Okay, but doesn't matter because it's equal to 0, so this will cancel out. What's left is 2 plus this will become 3 x minus 1 raised to 2. So this is my final answer. So this is my number 8. So first step, I'm going to use to find the first derivative. So this become cos x. So we know your second, and this is just negative sine x. Third is negative cos x. And your fourth is equal to sine x. You can continue on, but I can prefer you to stop at the fourth derivative. Then we simplify. So when your x is pi over 2, to sine here is equal to 1. So your cos pi over 2 is equal to 0, so it's 0 all over 1 factorial x minus pi over 2. Negative sine pi over 2 is equal to negative 1, so minus 1 all over 2 factorial x minus pi over 2 raised to 2. Next we have here cos pi over 2 again is equal to 0, 3 pi times x minus pi over 2 raised to 3. Next we have here sine pi over 2 is equal to 1 over your fourth factorial x minus pi over 2 raised to 4. Simplified, you have 1 minus, this will become 1/2 x minus pi over 2 raised to 2. Next we have here 1 over 24 times x minus 4 pi over 2 raised to 4 plus the rest. So this is my final answer. So this is our last number. Again, so first let's start with the first derivative. Okay. So again, this is the chain rule. So we have negative 4 sine of 4x. Here second, here we have here negative 16 cos 4x. Here third, so cos will be negative sine, So this will be 64 sine 4x here 4 is equal to 2 times 4 is 256 cos of 4t. We can stop here. So we evaluate each. So cos 4 times pi over 2 is equal to 1 plus negative 4 sine 4 times pi over 2 is equal to 0. We have 1 factorial times x minus pi over 2. So minus, we have here 16 cos 4 times pi over 2 is equal to 1. So it's 16 all over 2 factorial x minus pi over 2 raised to 2. Next, we have here sine, so in no sine is equal to 0. So we add here plus 0 over 4 factorial x minus pi over 2 raised to 3. Next, we have cos again, so it's plus 256 over 5th factorial times here x minus pi over 2 raised to 5. Simplified, so we have here 1 minus, this is 8 x minus pi over 2 squared. Next, we have here plus 32 all over 3 x minus pi over 2 raised to the 5th. Oh, sorry. This will be a fourth. Plus so on and so forth. Save those two here. So this is my final answer for my last number. Today I learned about the Tyler series and the Baccalaureate series. This actually brought up in Calculus 2, but we are able to finish it because of the lack of time, and we focus more on the derivatives and the integrals. And thanks for watching, and see you in the next video.